Hello, in this video you learn how to use SharpCompress for archiving, essentially compressing files, all kinds of files, and more importantly in all kinds of formats, from GZip, from zip to tar to rar, and all kinds of compression types as well, not just archive types but compression types. So all of that is available in this library and you can choose, and there's also two different sort of arrangements on how you can actually start compressing. There is something sort of more native in C# and .NET, but this actually gives you that full control and all these different archive types as well as compression types. Now, an archive type is essentially a file type, the way it is arranged, how you can look it up, and how you can uncompress it, decompress it rather, and the compression type is essentially how compressed it is, in what way is it, maybe there's a loss of data possibly, maybe it's faster, maybe it's slower. The slower it is, the more compressed it is. Usually that's the rule of thumb in that. But let's take a look at a couple of arrangements, just a basic zip sort of arrangement, and then another one, and just those two different ways to actually write this. Now, this example will be available on Patreon. It's quite in-depth one. There's all kinds of things in one single file, and you can run it quite easily. You don't need to sort of set up anything. It will just run, it will create archives, and you can also look up. So we'll take a look at the looking up part as well. But let's start with something simple, just this zip archive with archive API. So there's two APIs. There's this archive API, and here we have the writer API. We'll get to that later, and there are a few differences. Let's look at the basic code and then I'll explain the differences. But essentially, for the archive, we just need the file path. You will, of course, need to, let's just quickly jump here, SharpCompress in the NuGet packages. You install that. One simple package, nothing too fancy, no additional setup as well, just a simple package. So once you have that, we'll have a path for the file to be created, and then we use using, so it gets disposed after we use it. Very important, because of course we're dealing with files which could be, let's be honest, very heavy files and very heavy arrangements. And then we create an archive. Now, as far as archive go, is we can kind of get into that a bit. It's sort of like a memory stream almost. So essentially you have a bit more control and you can't go back to anything. So you start with some, you can actually go back, I should correct myself. You can go back to it, and it will be sort of perhaps more trustworthy, you might say. In that regard. The streaming, however, that would be more different. You get something, it's a bit quicker, you don't overload the memory, it just writes and writes and writes whatever it gets. And it can be perhaps a problem in some places, depending on how you arrange sort of the wrapper for it. But essentially, the create archive, if you have a desktop application or something of that nature, that's where it would be used, because you access the whole file, and the same with reading, you will see later. So you access the whole thing and you write the whole thing, and you have a whole thing ready to write, and that's all great and good, and you have a perfect, reliable arrangement. The streaming, that's where you have, say, TCP sockets coming from the network. The data is coming from a network, and you're archiving that, and then maybe resending it somehow as well. So that's more for those arrangements. Now, as for how it actually works, we use zip archives from SharpCompress, and as you can see, archives.zip. If you want another type, you'll use, obviously, not zip archive. In this case, we don't add too many options, but you can add options as well for this arrangement. We'll take a look at that in the stream. And then we combine some paths. Essentially, we have a TXT file and CSV file, just randomly created, a very basic sort of arrangement. And again, download this example from Patreon. play around with it if you want to learn more about actually creating these files. But then we just get the directory, then we open file write, and we write to the zip file. So essentially what it does, it will take those previous files, it will read it will read the bytes for it, and it will write the bytes to a new zip file, .zip file. And then we get to the compression type. Now in this option, it is deflate. And it's something, not exactly something you can choose so freely. So in this case, we have zip archive. And if you look at this, for example, all these options will be available, but they will be available for all the other archive types. And not every archive type, like we have here, can use the same compression type. So whenever you create something, you kind of just have to quickly look it up online, which is very easy to do these days, and just see exactly what you want. The main sort of choice will be, of course, whatever type you need. If you don't need a type, then you're just looking essentially, do you want the speed? Do you want the quickest for both reading and writing? Because that will sort of be the same. Or do you want the highest compression? Because you can put folders and things, lots of files essentially into an archive. You can compress it, but then the size, the total size will still be the same. So there's usually no point in that. Usually when we use it programmatically in this sort of an arrangement, we want to actually compress the size. So you'll probably want to go with something a bit faster, perhaps not as slow, but then it doesn't compress as well, or maybe you want the slowest and just the best compression. If you're, for example, saving massive files or just loads of different files, and it comes out sort of a reasonable size, then maybe it's worth to have a sort of background service to actually compress them and store them in that way, because the storage will be cheaper, and if the storage will add up at some point. And if you want to learn a bit more about background jobs in .NET, take a look at the previous video on this channel on how we use quads to schedule jobs, as well as RabbitMQ, which can be quite useful even in streaming arrangements sometimes. Something to kind of take a look at. But essentially, we open write, and then we have zip writer options, and then we just create a little file. Now, this is a kind of fancy arrangement, but we just take a length and length of bytes that were written. Now, let's get into the writer API. This will be the very similar arrangement, exactly the same actually, and it will create a zip archive, but it's a bit different. Now, for the streaming API, for the writer API as it is called, but essentially it's more of a stream API rather than loading the full thing and dumping into the full thing essentially. We need to use now two using statements because, again, whenever you work with files in the modern sort of .NET C# arrangement, it's always the best thing just to use using, whether it's a SQL Server connection, some other sort of connection of that sort, or a file stream connection, or whatever connection, memory connection is. Whatever you load, you need to expose, sort of get rid of rather, at some point, you expose it to the method and then you get rid of it all, you flush it down. This way it's the best because you automatically get that. So you don't need to do all the sort of writer.flush and writer.dispose, and you don't know which to use and which library and which arrangement. Best to just use all these using arrangements, perfectly valid these days, have been around for a few versions of .NET for sure. So for this arrangement, we open write, we sort of create a file path and open essentially a file stream to that file, nothing too fancy, and then we use that stream to write some data, some specific data, to that file. Now, in this case, the options are basically the same as previously, nothing to look at here. We use zip and deflate. Again, you can change them around and you can use different writers. So the interesting thing here, we don't use a separate sort of construct a separate class for the different writer types. So we just use archive type zip in this case, and of course you could use any of these other ones, and we'll take a look at the other example just to kind of take a look at it. Essentially nothing too different there, but in this case we get bytes, so we could have a memory stream, and then we just sort of slowly and simply and somewhat reliably write the memory stream in this case to the file stream, which it will be, but it's sort of generating that new file along the way. So you're not just writing the same sort of object that you have, say, .csv file from memory stream to a file stream. You're also at the same time combining and creating a new stream for the actual zip file. And then we just use write all, and then we can write all the directories as well, because we have different directories here and here. So the actual archive file will take several different files. You can see right here we have write readme, write report, and that will essentially become a folder that's archived. So that's very useful if you have some job that requires to generate something, and maybe you send a mail link, maybe it shows up in some web browser arrangement, but you just sort of have to collect the data and generate, and then you notify the user that it's all ready and good. They do this with bank statements, for example. You don't necessarily get it right away, you just get a link to download. Or sometimes now better providers for banks, they just do it right away because it's not a massive undertaking really. But some systems are of course legacy systems, and they take slower and they have to connect with more things. So depending on which arrangement you might be working with, it might be just notification or just email notification when you can download it and it's ready. But just combining sort of many files into one folder and then allowing the user to download, that would be one of the use cases for something like this. But again, it doesn't even necessarily have to be memory stream. You could stream from a socket or something of that nature. So many sort of different arrangements you can do. And then the search option, it will essentially allow, in this case, to search all the directories in that archive. So when you double click on a .zip file, you can look up what's in there. You can't open it because it's still archived, but you can look it up, what's in there, so go through it and then extract everything from it. So that's the arrangement here. Now let's take a look at the other one, tar.gz, GZip, something like that. Very sort of similar. This is now the writer we are using for this one, but if we compare to the previous writer, that's where we're going like this, there's no difference at all essentially. So just like with our files, but as I have mentioned in the beginning of the video, you do need to match the archive type with compression type, because some of them both match. And of course, the important part is actually choosing it. Again, the previous example, we have some bank statements, several different currencies, for example, CSV files, okay, but we want to put them in one single download, so we probably need to combine them in a simple zip, or we probably wouldn't do tars on that one, but just simple zip. So then, okay, we don't care about any compression really. It's not worth the effort for the actual server. It's not worth server resources, and that's really what you have to consider. But let's say you have a bunch of video storage, massive things that you actually need to store for years, and storage does cost money at some point, at some level of terabytes, probably not gigabytes these days, certainly. but it will cost money at some point. Plus, if you just want a quick download once in a while and you need that specifically, and you can put the burden on of decompression towards the actual user, then it is very worth considering higher compression. And yes, it will take slower, it will take perhaps more work on your CPUs, but again, it can be worth it. But the actual arrangement here, we are archiving just simple config files, say app settings.json, or whatever it may be. And again, we all combine the files, write all, and then we get bytes just for little sort of end arrangement, just so we can describe how the file actually works, and all that sort of stuff, and what we have there. And then we put in a memory stream and memory stream and write. So we write it all. We just use write or write all. Write all will write the combined arrangement. Write will just write whatever you specify specifically. So kind of a simple thing here. The interesting thing is the extraction. The writing of it, it's kind of straightforward, and of course the extraction, perhaps you wouldn't use that quite often. Perhaps you would be checking what's been sent to your server and extracting and making sure it's exactly what you need and whatnot. So just a quick look at it. Essentially, we just need to find the file that you have in your directory, and then we use open archive. We can use zip archive or other options, but just like we create archive, we open archive. And if you worked with files quite a bit in C# and .NET, you can probably notice these are essentially just sort of file streams, because and the arrangement as well is very similar to that, which is a good thing. Of course, it makes it easier to understand and use, because if you have a file stream, you open read or open write, open read write, or open or create an open, and then you access that stream to either write or to read. And this sort of arrangement is exactly the same. However, of course, we do have certain things in here, and we have the entries in the archives. So these will be either the main directory or subdirectories, and then we have all these sort of different files that we can change or take a look at them. And by key, we can actually look what's been compressed into that archive, and then we can look it up. And then let's take a look at the extract with reader. Again, same thing as writing. The only thing now we get a stream, which again is probably a bit less useful than actually writing from a stream, but it can be used in some cases as well. So kind of interesting to know and good to know that it does exist. But again, we're using 2 times, because we open the read from the actual path and then we access the actual stream. Now, if it wasn't a file stream that you're reading the file, it might be coming from a network as well, so we might be able to access open reader from the network. But then reading is exactly the same. We just look for it to be a directory, the main directory, and then we see what's been extracted. Now, some other quick useful features. We also have ability to kind of not just extracting it, right? Because here we extract, we write to an actual file. So we read what directory it is, we write to the actual file, and we take the destination. Whatever destination you set, you could write to the stream as well, to another stream. Just take from your one sort of long storage place to your short-term storage place, if it's something very heavy perhaps. But you can also just simply look it up not just look it up for extracting, but look it up for well, for lookup purposes. So you get the file path, you open the archive. Again, this is the archive option. So if we go back for extracting, we still need to open the archive. And that puts a bit of a load, so perhaps streaming is better for that option, especially in this case, we go through the entities for the entries and the entities in the entries essentially, and we write a directory. And then here again, we need to open the archive, and the archive itself actually has some data. So you can see you can read the type and you can read the entries. And that's quite useful because you can simply, in your storage arrangement, perhaps you have different needs for different kinds of files or different kinds of sizes to be written, or perhaps you just store the IDs of files in a database and some are faster, some need more compression. So you can actually read the archive type, and based on that, and only based on that, you don't even need to reference your database on what the type was. You can take a look at it and extract it accordingly, because as you can see, we have open archive. Okay, total entries we can see, but after that, when we look at different entries, we can just look it up like this. And even here, going back to the actual extraction, you can open the reader, and it comes from reader factory. Again, it's not archive type defined, so you can just if we go back here quickly, you can look up the archive and see, okay, this is this type, so we use extraction for this type. You can certainly do that. So there's sort of plenty of ways to look up actual data that you have and extract exactly what you need, and just sort of arrange things in your way. Because again, some of these arrangements can be quite costly in terms of server resources, not just memory, not just CPU usage or disk usage, but all of those things. So it's very important to determine, do you actually need the compression, or do you just need to create essentially a downloadable folder, because most systems probably sort of prevent downloading folders as such. You need to compress in a little zip thing. Okay, that doesn't cost any resources at all, basically speaking, compared to at least something like say GZip 2, which is a very high compression and it's a lot slower, and it will use those algorithms. Also, there are some different algorithms for different types of data, so text types, images, the ones that are available still will have a bit of a difference. So something to certainly look into before you actually implement this. And this code will be available on Patreon if you're interested in streaming and sort of arranging tasks in perhaps timely manner for CPU usage. Perhaps take a look at Quartz to do sort of hourly, daily, or whatever scheduled jobs, and take a look at RabbitMQ to kind of do a messaging queues and things of that nature, and perhaps the minimal APIs. There's a couple of videos on this channel covering all the greatest and latest, and just the general getting started with minimal APIs in .NET 10, which can be useful in all these sort of backend arrangements if you want to have a clear control of things or look up things directly from your own API, from your own arrangement. And with that said, we will conclude this video.